Section 5.3 Proportions. Okay, let's start with just the definition. A proportion states the two ratios or rates are equivalent. And just remember the difference between ratios. A ratio, the units are the same, and rates, the units are different. That's the only difference here. Okay, so for example, let's take a look at these two rates and have it make sense that these in fact could be represented as proportions. So the rate $20 for 4 hours or per 4 hours can be written in this manner, and since it is a rate we need to keep the units. Is equivalent to, so that would mean that it's equal to, so here you can take the is equivalent to and that justifies the equal sign, and then you have the second rate of $40 for every 8 hours. And it makes sense if you take a look at this. When I double my hours, I also double the amount of money that I make. So in an intuitive level this makes sense. One thing you'll be asked to do in the homework is just simply write a proportion, and you'll be giving something like this. And this is very simple. So here we have 3 feet is to 9 feet. Now notice these units are the same, so these are going to be ratios. So if we want to write 3 feet to 9 feet, we would write it like that. And then as would be equal to, and then 12 feet is to 36 feet. So as two ratios set equal to each other, this would be the proportion. Since they are ratios and the units are the same, these units can cancel each other out, and the final written form would be as follows. And again, common units divide out and are not written. So this is what happens with ratios. Now let's take a look at rates. Same process, it's just a rate instead of a ratio. So I'll just go ahead and click here. We can see that the first rate is written right here, and the second rate is written right here. Since the units are different, they do not cancel out, so you have to write them with the proportion. Now there's a few ways to verify whether in fact the proportion is true. Just making the claim doesn't necessarily mean that it's true, so let's take a look. One way to do this is, since proportions involve two fractions, you can simply reduce one or both fractions to lowest form, and if they are equal to each other, then it is a valid proportion. So let's take a look at this proportion here. Now 6 over 7 does not reduce, so I'll go on to the 32 over 28. Well, they're both even, so I'll go ahead and divide them both by 2. Well, 32 divided by 2 is 16. 28 divided by 2 is 14. Both are still even, so I'll go ahead and divide them again by 2. 16 divided by 2 is 8. 14 divided by 2 is 7. So what I have in this case, I didn't change the first one. The second fraction reduced to 8 over 7. Well, clearly these are not equivalent to each other, and so this proportion is false. It is not true. Another example here, both fractions require reduction. So we take a look at 24 and 52. I'll just be lazy and say they're both even. I'll divide them by 2. 24 divided by 2 is 12. 52 divided by 2 is 26. Still even, so I'll go ahead and divide them again by 2. That would give me a 6, and 26 divided by 2 is 13. So my first fraction reduces all the way down to 6 over 13. Let's go ahead and tackle the second one. Well, these are both even, so I'll just go ahead and divide them by 2. So 36 divided by 2 is 18, and 78 divided by 2 is 39. Well, they're not both even, so 2 won't work. Let's try 3. Well, 18 is divisible by 3, as is 39, so I'll go ahead and divide both of these by 3. 18 divided by 3 is 6, and 39 divided by 3 is 13. So the second fraction reduces to 6 over 13. Obviously, these two fractions are equal to each other, and so this proportion is true. Okay, that's method 1, just reducing the fractions in the proportion to see if they are equal. A second method, and probably the more common method, is going to be using cross products. To see whether a proportion is true, you multiply along one diagonal and then multiply along the other diagonal. Okay, what do we mean by a diagonal? So here's a diagonal here. We take the numerator of one fraction, in this case the 2, and we multiply it by the denominator of the other fraction. So 2 times 10 would yield 20. Now we do the same thing to the other numerator and denominator, the other cross product. Well, 5 times 4 is 20. And the cross products in this case are equal to each other. So that means that this is in fact a valid proportion. If we had different cross products, then the proportion is false. Okay, let's do another example to see if this is in fact a valid or true proportion. So let's do the cross products. 9 times 12 is equal to 108, and 4 times 27 is also equal to 108, and since these two numbers are equal to each other, the proportion is true. Okay, now this is an ugly looking proportion, but don't get freaked out because cross products are just simply multiplication. And so the first cross product that we're going to do is, and I'll kind of do a small arrows here and just kind of rewrite this. This is going to be 4 1/2 times 13. I'll just write it as 13 over 1. And with multiplication, if you recall, we want to go ahead and convert any mixed numbers into improper fractions. So 4 times 2 is 8 plus 1 is 9. So this is the same thing as 9 over 2 times 13 over 1. We get no cancellation, and when we do the multiplication, we get 117 over 2. Okay, so let's do the other cross products. We'll do it in this direction. So this is 3 3/4 is going to multiply 18. I'll just make it a fraction. Let's convert the mixed number to an improper fraction. 4 times 3 is 12, plus 3 is 15. So that's 15 over 4 times 18. Well, before we multiply, we have a cancellation. We can divide these both by 2. So 4 divided by 2 is 2. 18 divided by 2 is 9. And now we can go ahead and do the multiplication. When we multiply 15 times 9, we get 135. And 2 times 1 is 2. And so we can clearly see that although the denominators are the same, the numerators are different. So these are not equal to each other. So this is not a proportion. It's false.